colligative properties. So in this module we will discuss about the colligative property relative lowering of vapor pressure, and more importantly we'll do problems on this. So let us see with the problems here. So problem number 1, the vapor pressure of pure benzene at certain temperature is given. A non-volatile, non-electrolyte solid weighing 0.5 grams when added to 39 grams of benzene with a molar mass of 78 grams per mole, then the vapor pressure of the solution is 0.845. What is the molar mass of solid substance? One thing, please be aware of the question that it is given non-volatile, non-electrolyte. That means it is not going to vaporize, or rather it is not volatile, it does not have volatility, which means we cannot apply Raoult's law on that. And non-electrolyte, that means it does not even dissociate into ions. So the number of moles will always be same before and after adding to the solution. So these are the two things we should always be checking out in the question, whether these two things are given or not. Okay, now let us see how we can solve the question. So let us write all the given conditions first. One is P0 benzene, that is the vapor pressure, pure vapor pressure of benzene, which is given as 0.850 bar. Next, P of solution, it is also been given, that is the total vapor pressure of the solution, which is 0.845 bar. So you could see there is a little lowering of the vapor pressure. So therefore we know that XB, which is a mole fraction, is the relative lowering of vapor pressure, which is P0 A minus PT by P0 of A, where A is that solvent. Here the solvent is benzene, so it is P0 benzene minus PT by P0 benzene. So we know that XB can, which is a mole fraction, can also be written in terms of number of moles, which is NB by Na plus NB. And for dilute solutions, Na plus Nb can be almost similar to that of Na, as in I can ignore the Nb factor, which is the number of moles of solute, right? So if I substitute that here, and we know moles are given by mass per molar mass, so therefore if at all I write down that, you can see here 0.5 grams, which is the weight of the solute, divided by molecular weight of the solute, divided by, now it is the number of moles of solvent, because I have ignored the number of moles of solute in the denominator. So number of moles can be written as weight, which is 39 grams of benzene, by the molar mass of benzene, which is 78. So this has been approximated, and that will be equal to, you know, the values already given. So 0.585 minus 0.845 by 0.850. So which makes us to get molar mass of that particular solid substance as 170 gram per mole. So after solving that equation, we will get approximately 170 gram per mole. So this is how we solve the questions when we need to calculate the molar mass using the relative lowering of vapor pressure fundamentals. Alright, let us go to the next question here. So in this question it is given that the vapor pressure of water at a certain temperature is 25.21 torr and 20 grams of glucose is added to 70 grams of water. So we need to find out the total vapor pressure of the solution. So let us try to do that. Let us see what are the given conditions here. I can assume the glucose as the solute, which is B, and water as the solvent A. So taking this assumption, now we will apply the formulas. And we know, as I said earlier, now glucose is a non-volatile, non-electrolyte solid. So even though it is not given, you need to consider it as a non-volatile and non-electrolyte solid. Now we know that P0 A is given, which is the solvent pure pressure, which is 25.21 torr, and we know moles can be written as given mass by the molar mass. So therefore we know the molar mass of glucose is 180 gram per mole. So if I substitute that, number of moles of glucose comes out to be 20 by 180, which is 0.11. So number of moles of glucose we got. Similarly, can we calculate the number of moles of water, which is 70 grams upon 18, which is 3.89. So we got number of moles of glucose as well as number of moles of water. Now in case of non-volatile solute, the vapor pressure is same of solute and solvent, a solution, right? So if that is the case, using Raoult's law, we can write P total is equal to P naught A XA plus P naught B XB, where we know that the vapor pressure of non-volatile solute is 0. So therefore I can say that P naught B is 0. So equation will turn out to be Pt is P naught A into XA. So therefore Pt will be equal to P naught A with the value which is 25.21 into 3.89 by 0.11 plus 3.89. So that turns out to be 24.5. So this much amount of pressure has been lowered down. So on adding this solute. So this is how we need to do the problems related to relative lowering of vapor pressure.